Hello, we're going to be doing the Senior Math Challenge 2025. It's meant to take an hour and a half. I'm going to do as much as I can an hour, see what happens. I'm trying out some splits in the top right. Don't think it's going to work. Probably I'll forget about it, but it's a fun way to try and keep track of how I'm doing. So, let us begin. Okay, Paolo has 100 identical cubes. Use something to build the large part of a solid cube. How many of the solid cubes are left? Okay, biggest cube is 4 cubed, which is 64. So 100 minus 64 is 36. Oh, no, it's not. The splits. Okay. 9 smaller. What fraction is shaded? Okay, so they connect. So 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 ninths. Okay. Oh, this is actually really annoying keeping track of the thing, but that's fine. What is this? Whoa. Okay, well, I can do difference of two squares. 25 times 24. Oh no, sorry. It's a plus b times a minus b. So it's 25 plus 24 minus, and then if I take out the minus, then it's 23 squared minus 20 squared is 23 plus 22. So that is 49 minus 45, which is 4. Oh, great question. Obviously, that was awesome, because I could take that out, make that a minus, difference of two squares. Oh, love it. So I write down 3 two-digit numbers whose sum is 46. The first number is prime, the second is square, and the third is even. Okay, so I've got 36. Let's try that. 3 two-digit number versus prime, so let's say, oh no, it can't be 36. So 25, 11, and 10. Wait, yeah, 11's prime, that's a square, that's 10. And that makes 46. Okay, cool. It's 10. Don't love I need to keep clicking that, but whatever. The latest shaded area, radii 1, 2, and 3. The area of the largest circle. What's the, okay, so small circle is pi. Shaded area is 4 pi minus pi is 3 pi. The big one, large circle, is 9 pi. So shaded area is 3 pi over 9. So it's 1 to 3. Okay. What's the value is? Whoa. So take away 1 and then square. So I've got, okay, so take away 1 is 2 and square is 4. And take away 1 is 3 and square is 9. And take away 1 is 8 and square is 64. I'll just do that again. Take away 1 is 2 and square is 4, and then take away 1 is 3 and square is 9, and take away 1 is 8 and square is 64. Great question. Very enjoyable. 100th term of the sequence. Oh look, that's 1, 4, 2, 4, 1, 4, 2, 4. Oh, that's really cool. 100th term, so that's the 50th term of this sequence. So that's, and that sequence is 6n minus 1, so it's just 299. Huh. We've got like 2 sequences over, like interwoven, I think. I feel like I might have made a silly mistake there, but I don't mind. We're trying to do it fast. That is 6n minus 1, isn't it? Yeah. 3 arcs of circles of radius 1, center of the circle. Wait, what the hell? P is the center of a circle of which RQ is an arc. There's an arc. Okay, so that guy just fits in there. That's the radius of 1. What fraction of a circle is that? That's also 1. Like, yeah, that piece just fits in there. I mean, it looks like it's 60. It looks like it's 60, doesn't it? Like, that looks like an equilateral. Oh, it is an equilateral triangle. Obviously, because they're all radiuses. So I've got pi r squared over 6, which is that one. Okay. 50 squares are drawn side by side on a line. First and last square shaded. Other squares must be shaded such that those. Oh no. Oh no. Oh no. Okay, so I've got shaded, unshaded. What's in the smallest and largest number of squares that can be shaded? Oh no. So the smallest amount of shaded. Okay, so we have this, which basically means every 3, so 1 and 3 are shaded, but the last one is also shaded. So 1 and 3 are shaded up to 48, and in 48, so 48 divided by 3 is 16, so we've got 16 shaded, and then 49 is unshaded, but then the next one is also shaded, so that's 17 shaded. So 17 shaded is the min, and the max is if I just do this 1 in every 2, and that's 25 shaded, except it's not because the last one is also shaded, which means that, but wait, that's the same because I can just swap round those last 2, so it's 25, so the difference is 8. That's another, that's not a strong suit of mine, I don't think. Okay, how many different squares are factors of 225? So that is also square, I know that. I think it's 45 squared. 5 times 5, 5, 2, 22. Wait, have I just done maths wrong? Oh, because I'm doing 4 times 5. 4 times 5 is 20. 4 times 1 is 16. Yeah, it's 45 times 45. So that's 9, 5, 9, 5. So I've got 9 squared times 5 squared times 40. Oh, it's 9 squared times 5 squared. Okay, so how many square factors? We've got 9, we've got 81, we've got 45, we've got 1. 4. 1, 9, 81, 45. Fun. Okay, 11. The diagram shows this. Ooh. Nope, excuse me. Go to that. Q is 20. PQ is 20. PR is 25. Okay. Bit of Pythagoras. So 25 squared minus 20 squared equals QR squared. So that's 5 times 45, which is, oh, that's 25 times 9. So that is actually 5 times 3 squared. So that's 15. Oh, I should have known that. It's 3, 4, 5, but scaled. Okay. P and M, rectangle triangle, the area is half of PQR. Okay, so PQR, the area is 150. The area of PMN is 75. So the area scale factor divided by half, so the length scale factor is dividing by √2, the lengths, because they are similar. So actually, all I need to do is think this is the same as this, so I just need to do 15 divided by √2, because that's the linear scale factor. Area scale factor is half, linear scale factor is dividing by √2. 15 over √2 is 15 √2 over 2. Okay, cool. Nice. Nice bit of Pythagoras, bit of scale. That's a great question. 3 different odd digits. I've done all of the 3 dynamics with 3 different odd digits. How many of them are divisible by 3? Okay, so if I choose a 1 here, okay, that is I don't just want to do loads of them, because that's not, and that's not, because that one is. Okay, and then okay, I understand. I choose the digits that work, and then I combination them. So that 1, 3, 5 works. So I can, how many ways they're rearranging that, which is 6. Then I could also do 3, 5. No, there's no way to get. Oh wait, whoa. 1, 3, does 1, 3, 7 work? No, but 3, 5, 7 works. 3, 5, 7 works. So that's another 6 options. And 9, 1, 5 works. That's another 6 options. And 9, 3, 5 doesn't work. I've just looked at that. I don't think 9, 3, 7 works. No. 9, 5, 7? That works. That's another 6 options. So it's 24. These are another, because here, how many ways are there rearranging 3 numbers? So I have 1, 3, 5, 1, 5, 3, all those. Then the ones containing 3, 5, 7. Then the one containing 9, 1, 5. Then the ones containing 9, 5, and 7. What have I not tried? 3, 1, 7 doesn't work. 7, 5, 1 doesn't work. 9, 5, 3 doesn't work. Yeah, that looks good. 5 congruent squares, each of. So that's 2 at least. 2 circles with the same vertices. Okay, here to here. That is the diameter. Right? Right? That's the diameter. Yeah. Okay, so 2A, 6A. Okay, so what I'm doing is everything between the 2 circles. So the little one, the little circle has this square, which that's 2A, that's 2A. That length is got 4A squared is plus 4A squared plus 8a squared equals 2 root 2a. That's 2 root 2a. Yeah, I know it's times root 2. So the radius is root 2. So the area of the little circle is 2a pi. Oh no, squared. 2a squared pi. So that's the radius of the little circle. And so it's 2a squared pi. Okay, cool. The bigger circle, if I do some Pythagoras here, I've got 2 squared plus 6 squared equals 4 is 40. And root 40 is 2 root 10. So half that is root 10. And then if I square that, so then the big circle is pi times 10a s squared. So what's the area of the region between the two circles? So that's the shaded region, right? Yeah, the shaded region is 8a squared pi. Cool, fun. I don't really want to delete my working out, but so I'm gonna. I'll be fine. Let's see what else I can do. Okay, the sum equations, we've got x plus 1 over y equals to 2, and y plus 1 over x equals 9 over 4. I have two pairs of real solutions. Okay, so I've got x, y plus 1 equals 2y. I've got x, y plus 1 equals to 9 over 4x. So 2y, I just times everything by y, times everything by x. 2y equals 9 over 4x, so y equals 9 over 2, 9 over 8x. And then what they say to say about integers, I know real solutions, and it's what's the difference to the possible values of x. There's some vietas, something's happening here. Okay, I got this. So I got x plus the reciprocal of this. So if this is 9x over 8, 8 over 9x equals to 2. Ugh. I'm going to times it by 9x, so 9x squared plus 8 minus 18x equals 0. 9x squared minus 18x plus 8 equals 0. Okay. How do I factorize this guy? Oh, wait. I want the difference between the x values. Oh, I don't know. Okay, so if I split the middle term, 76. Oh, there's so many factors. Oh, it's 36 and it's not 36 and 2. It's not 18 and 4. It's can I just blag this? Is it 3x minus 3x 2? How about 9 and 8? No. Let's check I haven't done this wrong. Okay. xy plus 1 equals 2y. xy plus 1 equals 9 over 4x. These are equal to each other. So 2y equals this, yeah? So if I divide by 2, I get y equals 9 over 8x, which is this. Then if I sub that into, let's say I sub it into here, I get x times 9x over 8 plus 1 equals 2 lots of 9x over 8. I could have subbed into that one. Whatever, same thing. So I get 9x squared plus 8 equals 18x. So I get, yeah, what did I get? No, it's the same thing. Okay, so I haven't made a silly mistake so far. Can I factorize this? Oh, it's 24 and something, isn't it? 3. No. It's 6 and 12. It's 6 and 12. Okay, so 9x squared minus 6x minus 12. X plus 8. This would be better if I could factorize quicker. X minus 2 minus 4. X. That's a 3. 3x minus 2. I could have just got it in the end. Whatever. So it's 3x minus 2. 3x minus 4 equals 0. X equals 2 over 3. X equals 4 over 3. And the difference between these is just 2/3. That was a nice question that took me too long. Oh no, I forgot to click this. See, that is classic. Too much to hold on to. Okay. The integer n is such that I am going to rub these out. Goodbye, working out. See you in another life. Okay, the integer n is such that p is equal to I, q is equal to I. So p is n minus 1. Q is 99 minus n. R is p minus q. So I just do n minus 1 minus 99 minus n, which is 2n minus 100. Oh, I need to do q minus p. I mean, it shouldn't matter really. I think I need to just try some numbers because this isn't working. Okay. So for example, if n was 3, so then p is 2, q is 97, and then I subtract that, I get 95, which doesn't work. Okay, so if p is, how about if it's an even number? Then p is 3, q is 96, and it's an odd number. Okay, so these ones, that also gets me an odd number. Whoa, is this random? There's definitely better ways I could be doing this. But let's just try another one. So then p is 4, q is 95, r is 95, r is 93, q is 91. So we can make every single number. Okay. Yeah. Okay, we can get a pattern here. I should have probably done better. Oh wait, are we subtracting from 99? If n is 2, p is 1, q is 98. No, q is 97, r is 90. No, q is 98, r is 97. Okay, so it's basically we're going from 97 downwards. The biggest thing it could be is if p was 98, q, no, if n is 98, p is 97, q, this is one of those ones that I know the students I have will have done so much quicker because I'm flapping around. N is 98, p is 97, q is 2, it's the opposite, so r is 95 again. Oh, so it's symmetries. Obviously it's symmetries. So in the middle, if I have, when are they the same? At 50? At 50. So if n is 50, then p is 49, and q is 49, and r is 0. At 49, p is 48, q is 50, why have I got r as 2? What? I'm doing something bonkers wrong here. If n is 49, the difference is 48. The difference here is 50, so the difference is 2. How did I get... I think I need to start again. I've lost my mind. Q is 50. Okay. If n is 3, p is 2, q is 96. I'm doing this all wrong. I'm starting again. This is an absolute disaster. Okay. If n is 2, then p is 1, q is 97, and r is 96. Okay, if n is 3, p is 2, q is 96, and this is 94. Going to 50, when 50, p is 49, q is 49, and r is 0. At 49, yeah, if I go to 51, it's the same as 49. So at 49, that is 48, that is 50, and that is 2. So how many? There's only one. Oh my god. What? Oh, because it's 49 and 51, it's doubled. That was cursed. That was cursed content. 7 minutes? When actually I just didn't lay my work out properly and I'm... Okay, we reset. What's the length of the side of the square? So that's also 2. That's also 2. The square, the circle touches the diagonal on 2 sides of the square. Circle radius of 2. And the length of the side of the square. Ooh, this looks fun. I'm just going to draw this. Let's make this a bit smaller. Let's do red. Okay, that's 2. That's 2. That's 2. These are 45. That's 45. So that's 22.5. That's 2. These are the same. That's 90, that's 90, that's 2. It's 22.5, which isn't great. What's the side length of the square? So I'm trying to find this length. Like, that's 2. Okay, so x squared plus x squared equals to 2c squared. So 2x squared equals 4c squared. So x squared equals to 2c squared. Now, in this guy, I've got, what do I have in this guy? I've got 2 squared plus c squared equals that length squared, which doesn't really help me like at all. And also I think I've just done some terrible maths here. Oh wait, no, we're looking at this. I mean, I just don't know what, I mean, if I did trig to find c, if I did trig to find this length, then I've got, but this is 22.5, and that's, no, that's 2 and that's c, so I'm basically saying tan of 22.5 equals 2 over c, so c equals 2 over tan of 22.5. Now, tan of 22.5, maybe I do actually know, because, okay, sine of pi over 2 I don't know my double angle for tan off the top of my head. I kind of want to cheat and look at the double angle formula for tan, but that's not really fair. Okay, sine theta over cos theta. So sine 2 theta over cos 2 theta. I'm doing something ridiculous, but I'm having fun. So I've got 2 sine theta cos theta over cos squared theta minus sine squared theta, divide everything by cos theta. So if I make this, yeah, so 2, oh no, divide everything by cos squared theta, yeah, that's what it is. Then it's 2 tan theta over 1 minus tan squared theta. Yeah, okay. So that equals tan 2 theta. If I want tan of 22.5, 2 tan theta over 1 minus tan squared theta equals tan of 45. Is tan of 45 1? So if I got 2 tan of 22.5 equals 1 minus tan squared of 22.5. So if I got tan squared plus 2t minus 1 equals 0, that's t minus 1 squared equals 0. No, it's not. You can't factorize that. That's fine, I can still solve that. That's t plus 1 squared minus 1 equals 0. I'm on an absolute journey that is going to have no use at all, but I'm having fun. Okay, t equals 1 plus or minus root 2. So we're saying, I think we're saying that tan of 22.5 equals to 1 plus root 2. Don't know. Oh, what the heck? You can leave. So I think that means c equals to 2 over 1 plus root 2. I think. I'm sure that's wrong. Like, I'm sure it's wrong, but I'm having fun. And then what we're trying to find, so x squared equals 2 lots of that squared. And this squared, oh god, look, okay. So that's 2 lots of 1 minus root 2 over 1 minus root 2 minus 1 minus 1 1 plus root 2 minus root 2, yeah, so that's 2 root 2 minus 2. But that needs to be squared, so x squared equals, wait, if I just root that and put it in, so then I times that together, and I've got 4 minus 2 root 2. Is 4 minus 2 root 2 an option? No, but 4 plus 2 root 2 is. That's wrong. I did that wrong. But I'm moving on, because I had fun. I've done that wrong. I'd actually like to come back to that, but I've done that wrong. And I did it stupidly, and I did it using some techniques I'm almost sure are questionable, but I had a good time. I kind of want to move all this working away so I can amusingly come back to it when I'm marking my answers. Yeah. Let's just grab all of this disgustingness and move it away so I can come back and laugh at my silly self afterwards. Oh, we're lagging. Okay, 2 circles full of 5 inches, so any one can be made. You choose one of the inches by summing up to 5 adjacent integers. What? So how am I going to get 21 with 3 numbers? So 21 minus 6 is 15. So 15 with 3 numbers is, I mean, there's loads, 5, 9 and 1. Oh no, wait, I need to be able to make all the numbers. I need to be able to make up all the numbers. Okay, I understand. If I need to make the number 2, I need another 1 somewhere, or I need the number 2. So I need 1 or 2. If I have 1, it has to go here. If I have a 1, it has to go here. But then I think there's probably limits what I can do. I think I can't have a 1 here, because I think if I have a 1 here, then this is 7, and to get to 21, I'm going to need a 9 and a 5, and then there's no way to get to 8, for example, which means one of these numbers has to be a 2. One of these numbers, we have to have a 2. Now, to get to 3, either I have a 3, or the 2 has to be here. If the 2 is here, then can I get to 21? So that is 8, so I need to make 13. To get to 13, I need, for example, a 7 and a 6. Now, I think this feels good already. 1, 2, 3. Okay, I can't do 4. Can't do 5. I can do 5, 6, 7. I can't do 8. So these maybe need to be the other way around. But I can't do 4 anyway. How am I going to get 4 in here? If this is a 2 and this is a 9. How am I going to get to 4? Unless I have a 4. 1, 2, 3, 4, 5, 6, 7, 8. To get to 9, I think I need a 9. 9. And there's no 10. How do I get to 9 otherwise? Wait, 4 could be here. 1, 2, 3, 4, 5, 6. We don't have a 7 at the moment. We don't have an 8, we don't have a 9. We don't have a 10. We don't have an 11. Wow, this is really interesting. This is really interesting. I kind of just want to keep trying stuff. This is a really nice, like, open thinking puzzle, where we're just adding stuff. Like, I guess I could put an A here and a B here and do like 1 plus A plus X has to equal to all these things, but I don't really want to. Okay, I managed to work out I need a 2. Because that's the only way to make 2, because I can't have a 1 there. So, but then if I need a 3, so if I put the 2 here, then I could put the 3 somewhere else, like that. 1, 2, 3, but I don't have a 4. And I don't need the 3 next to the 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 12 here? That's another 11. Oh, 12, 13. Does this make 21? No, this only makes 19. So how the heck am I making a 3? How the heck am I making a 3? Unless I have a 3. But if I have a 3, I need a 2. I think a 2's here. I can make a 3. So how am I making a 4? To make a 4, I need a 4, or I need this to be a 2. And if this is a 2, then I've got 6, 10. That doesn't work, so I need a 4. If I go 4 here, I gain a 6, which is useless. So if I go 4 here, now, if I get to 21, this has to be a 9. But it can't be a 9. We're told it can't be a 9. Excuse me, go away. We're told this has to be a 9. It can't be a 9. Ugh, I could go the other way. If this is a 2, then how am I going to make a 3? Unless I have a 3, which goes here, but then that doesn't work. It's like, oh my god, it's not 0 to... It's not the numbers 1 to 9. I can have a 10. What a waste of 8 minutes. I thought I was going to do this just 1 to 9. That is so funny. That's classic math challenge. That's classic me under pressure doing these videos, is I don't actually think about what, because I could just have a 10 here. But there's no 4. So burn off the 3, have a 2 here, then have a 4, 1, 2, 3, I need a 4, so let's do the 4 here, and then and let's have a 10 here, and let's see what happens. Because that makes 19, 20, 20. That makes 22. But those add to 21. Okay, so 1, 2, 3, 4, 5, 6. There's no 7. If I had a 2 here and a 3 here, then that adds, then I need a 10 here. 1, 2, 3, 4, 5, 6. There's no 7. Can't have a 2 there. No. 2 has to be here. Can I have a 3 here? In which case I don't need a 2 there. In which case to get a 4, I need a 4. So well, if I had a 1 here, then that adds to 8, 10, adds to 11. There's no way this is going to work. 1, 2, 3, 4, 5, 6, 7. I'm saying no to 3s. Unless we did 3, 2. I mean, I could chuck a 21 in there. And then I've got 1, 2, 3, but I don't have a 4. Can't have a 4. I think it can't be 3 either. How about if I go 7? If I go 7, then this is a 2. Then I've got 1, 2, 3. I don't have a 4. What does this all add to? No, don't have a 4. Don't have 3. No, I don't think it can be 7 either. I'm not even sure it can be 10. Because I need a 2 and I need a 3. Unless 1, 2, 3, 4, 5, 6, 7. There's no 8. No clue. Guessing 11. Absolutely baffled. How do I skip? Yup. Okay. 18. False integer 20, 25. The first integer a 3. What time have I got? Yeah. So that's a 3. Every 2 consecutive forming numbers is divisible by either 17 or 23. Okay, so if I'm 7, then I'm 7, I'm 34, I'm 51, I'm 68, I'm 85. If I'm 23, then I'm 23, or I'm 46, or I'm 69, or I'm 92. Okay, ooh, this is fun. So this has to be a 4. And then that has to be a 6. And then there's 2 options. Ooh, this is fun. Oh, and there's 2 options. Okay, so now I can either go 9 or I can go 8. If I go 9, then the next thing's a 2. If I go 8, then the next thing's a 5. If I go 5, then the next thing's a 1. Then I go 7. But it can't be 7. That one doesn't work. So then 3, 4, 6, 9, 2, 3, 4, 6. Oh, it's going to be 9 or 8. No, it's not. Oh, wait. How's it 2 options? Oh, I get it. Because what's happening is, after the 6, there's 2 options here. And then after that, it works up until there. So basically, it's either 2 plus 5 or 3 plus 1. It's either 7 or 4. And because 4 is not an option, it's 7. Let's go. Oh my god, what? We've got a shirt, 3 pairs of shorts, 3 shorts, plus 1 pair of socks is the same as... Oh, okay. Shorts is X, socks is Y, shirts is Z. Oh wait, I did 18. Is Z. So, you know what? Shirts is P. I'm going to go ABC. So, 3 pairs of shorts plus 1 pair of socks is 2 shirts. 7 pairs of shorts plus 4 pairs of socks is 5 shirts. Ian has the exact amount of money to buy 9 shirts. 9 shirts equals how many full kits? Oh, sorry, shirts is here. Well, if I times this by 2, 6A plus 2B equals 4C. So if she has enough to buy these exactly, then she has enough to buy this and this exactly. So she has enough to buy 13 A's plus 6 B's plus 9 shirts. So the limiting factor is she only has enough to buy 6 socks. Because if she has this much, let's not use S, then she has enough to buy 13 A's, 6 B's, and 9 shirts. Oh no, that's not true. Because she can't afford 9 shirts. She can't afford 9 shirts because that's twice as big. 9 shirts equals this. But she needs to buy the shirts and she needs to buy everything else. Why am I using S? How many complete football kits could she buy for the same amount of money? So if 9 kits is 13 plus 6 B's, 5 is, I'm trying to find A plus B plus C. But not really, I'm trying to think how many A plus B plus C's fit into this. I feel like it's 3. Okay, so she can buy 9 shirts, which means she can also buy 13 of these and 6 of these, but she also needs to buy some shirts. So if she bought so we had 9 shirts equals 13A plus 6B. We know that 3A, we know that 2C, we know that 5C equals. Yeah, this one's not really allowed, but I do know how much that's worth. But I also need some shirts. I don't know. I pause. Oh no, I don't pause. I skip. I don't know. Gonna come back to it. Because it'll really only have 5 minutes. And I got a feeling some of these might be easier. Or at least like more skill set. That's an interesting question. I need to rethink that. Okay. This one. Oh, we can kind of, this looks very factorizable. Okay, so we've got, if I look at this, So I've got y minus x equals 2025xy. I'll just times this by xy. So I've got x minus plus 2. Oh, this looks cool. Oh wait, I know that. So if I've got x plus 2026 xy minus y over that was this, so over 2y minus y minus x minus 2x. Just going to give me anything? Oh, x minus y is minus this. Two y minus y, 2y plus x minus 2x is y minus x. Yeah. Because this is just minus this. So I've got minus. So I've got xy over y minus x. No. Oh wait, xy over. Whoa! Look at this. Wait a minute. It's 1 over 225 because xy over y minus x equals 2025. Okay, I did that really scrappily. I basically like subbed this in here, but the negative, cancelled it. This went in there. Wow, that actually popped out really nicely. Okay, let's do the one I think might be easy, which is 22. Okay, maybe not really. No, why do I keep getting note? Okay, maybe not really easy, but let's look at it anyway. N aardvarks. Until I eat that many ants. How many ants does each animal eat? Can't factorize that. N plus 5, but I can complete the square. Let's see what happens. That's the number. The same whole, I mean, I could just sub these in. The same whole number of ants. I'm not sure I really understand the question. So am I dividing by 2? Like, this is the number of 12 anteaters ate. So am I just doing n plus 10 squared? 75 plus 24. 99? No, what? If n is 1, I get 46, which doesn't work. If n is 2, I get 4 plus 40. I mean, you can kind of just cheat this. kind of. I think if n is 1, no, if n is 2, you get 4 plus 40, you get 69. That's... No, we're dividing, timesing it by 2, so... then if n is n squared plus 20n plus that is 2 lots in that hard box. Is that right? No. Wowzers. It's been an hour and I've not done well. Let's just pause. Let's pause. Okay. It's been an hour. That was hard. That was hard. And also I did not feel in good form. Did not do 19. Did not do 17. Did 20 and then didn't even look at 21, 22. 24, 25. Even though they look kind of interesting. That looks really cool. I'm out of time. Okay. That was really cool. Really hard. Just really hard. I'm going to spend a lot longer with some paper on some of these other questions. For now, let's mark what I got in an hour. So I'm going to pause, come back with the answers, see how well or badly I did. Okay, got the answers. Let's mark. So, 1, C, 2, E, 3, E, 4, A, 5, A, 6, B, 7, D, 8, B, 9. Okay. Oh my god. What did I miss out? 1, 9, 25, 45, 15. Oh my god, I'm such a melon. One, 9, 25, 8. Oh, and obviously 225. Wow. Wow, mistakes for days. 11B, 12D, 13D, 14B, 15B, 16A. Oh, no way. My janky method. My janky method. So PR equals PO plus OR. Oh, wow. Yeah, of course. Of course. I got it right though. 17. I said E, but it was D. Yeah. Yeah. 18C. Yeah, that was cool. I really like that. 19. Oh, this looks cool. Okay, I'll come back to it. 20E. Yeah, really like that. Really fun. Didn't try 21. Didn't understand this. didn't understand that. And then don't want to look at the other things because didn't get to do it. Okay. Overall, we made 2 disastrous silly mistakes at the beginning, but we did get 1, 2, 3. Well, I can count the ones I got wrong. 1, 2, 3. 3 wrong. And I didn't do 1, 2, 3, 4, 5. Oh. No, I didn't do. Yeah. And so, what that means is my score is. Sorry, how many questions did I get right? I lost 8, so that's 17. So, 17 times 4 minus 3 plus 25. That's not very good, is it? Oh no, 17 times 4, that's a bit better. Okay, 60, 34, 68 minus 3 is 65 plus 25 is 90. Really, those 2 silly mistakes, I should have another 8, another 11 if I'd made those silly mistakes. But we're good. Okay, very enjoyable. Also hard. Can't lie, hard. The ones that I got wrong, or the ones I didn't do, I'm gonna try again some other time, just for fun, on a piece of paper probably. But yeah, it was great. See you in the next one. Bye.